Good afternoon, ladies and gentlemen. This is section 7.6 and 7.7 of Mrs. Quinn's Algebra II class. And we're going to start talking about exponents, powers, radical exponents, rational powers. And so we're going to start with number one. If I'm looking to solve, and hopefully this first one is a review, if I'm looking to solve x squared equals 100, I'm going to have to do the opposite power. So I would square root both sides and get a positive and a negative. True? On this side I get x, and on this side I would get 10 and negative 10. Now, what we want to realize is, at this point is that is the same operation as raising to the 1/2. If I raise to the 1/2 power, that's the inverse operation of a square root. 2 times 1/2 would be 1. Over here I get x, and over here I get my plus or minus 10. For number two, if we wanted to explain how we can use the graph of y equals x to the 8th to estimate the real 8th roots of 3, here's what you're going to have to do. X to the 8th we know is going to be a super skinny parabola that looks like this. Agreed? Y equals 3 is going to be a horizontal line like this. Now look at that graph and think about how we could estimate the real 8th roots. There's some non-real roots of 3, but let's start with the real roots of 3. Thoughts? Hopefully, you would agree that you could find those intersection points. You can find intersection point here and here. One's going to be positive and one's going to be negative. This intersection point is going to happen at about x equals 1.41. This one's going to happen at about negative 1.41. Double check on your calculator and make sure you agree. So, oh, I said that wrong. Sorry, that's a 1.14, I think. There we go. All right, let's go ahead and look at our roots. Saying 27 to the 1/3 power is the same thing as saying the cube root of 27. The notation is different, but the concept is exactly the same. And that's going to be a positive 3. What if I want 25 to the power of 1/2? Again, that's the same thing as the square root of 25. And hopefully you would agree it's 5. How about 81 to the 1/4? It's the same thing as the 4th root of 81. These notations mean exactly the same thing. And what multiplied by itself 4 times gives us 81? 3. How about 8 to the 1/3? Hopefully by this point you would agree it's the cube root of 8. It doesn't matter which notation we use. What multiplied by itself 3 times to give us 8 is 2. All right, I'm going to just use rational powers. Now I'm going to stop writing it in radical notation. I know you're more familiar with this notation, but hopefully now you see them as the same thing. And so if I want to take the 4th root of 16 over 625, I am asking myself what multiplies itself 4 times to give me 16. Hopefully you'll agree 2. And what multiplies itself 4 times to give us 625? Hopefully you'll agree 5. And finally, 115 to the 1/3. This we're not going to be able to simplify in a brilliant brain, so we're going to have to use our calculator. So type in 115, and then use your caret symbol and do in parentheses 1 divided by 3. And this isn't going to be exact, so let's say it'll be approximately 4.86. Let's use 2 decimal places. All right, find all the real solutions of x cubed equals 343. Here, to solve, we're going to do the opposite operation, right? In fact, my screen is looking a little full, so I'm going to go ahead and clear out what I've done and begin again down here. Let's move this up. If I'm looking to solve, I'm going to do the opposite operation to both sides. Over here it cancels and leaves me with x. And remember, when you take an odd root, you get 1 answer. When you take an even root, that's when you get 2 answers, a positive and a negative. So let's start right here at 343, and we ask ourselves what multiplied by itself 3 times gives us 343, and hopefully you'll agree it's 7. If you don't recognize that, on your calculator, do 243 to the power of 1 divided by 3. These are your keystrokes, and you'll see that it is indeed 7. All right. For this next one, I'm going to need a little more space. To show that 1 minus I is a fourth root of -4, we are simply going to raise 1 minus I to the 4th power. And we want to show that we get -4. So over here I'm going to rewrite it as 1 minus I squared times 1 minus I squared. And hopefully here you'll agree I get 1 minus 2I plus I squared. 1 minus 2I plus I squared. And hey, what is I squared? Wouldn't you agree with me that I squared is just -1? So we'll plug that in. And then when I simplify these, what is 1 minus 1 in both of those factors? It would cancel to 0. So now I'm left with -2I times a -2I equals a -4. And when I multiply those together, I get a negative times a negative is a positive. 2 times 2 is 4. And I times I is I squared. Now I squared actually equals a -1. And we end up with -4. All right. Between which two consecutive integers is the real solution of x to the 5th equals 500? We know that 3 to the 5th is 200 and, let me double check, 43? Yeah, it equals 243, so it has to be bigger than that. Let's check out 4 to the 5th. 4 to the power of 5 is 1,024. So it's bigger than this one and smaller than this one. So the integers that the solution has to be between would be 3 and 4. All right, if I want to write the expressions 9 to the 4th, 9 to the -4th, 9 to the -3rd, and 9 to the -1/2 as powers of 3, I am going to first write 3 squared to the -4th, 3 squared to the -3rd, 3 squared to the -1/2, 3 squared to the 4th, and 3 squared to the 7th. Here I'm going to get 3 to the -16th. Here I get 3 to the, sorry, this should have been a 4. Can't read my own handwriting. Sorry. 2 times 4 is 8. Here I get 6. Here I'm going to get 3 to the -4th. Here I get 3 to the 8th. And finally over here I get 3 to the 14th. Now if I insert missing powers of 3, notice, and I'm mainly looking here between these two and these two, if I insert a power of 3 right here, aren't I missing a 3 to the -7? And so that would have to equal 9 to what power? If that's smack dab in between -4 and -3, wouldn't I get a -3.5? And if I look between 6 and 4, I'm missing a power of -5. That's between the powers of 3 and 2. So that should give me 9 to the -2.5. We'll look at more equal or congruencies in class tomorrow, but that's something that you should notice. All right, if we're going to simplify this radical here, we're going to start with the cube root of 8 and raise it to the power of 5. The cube root of 8 is 2, raised to the power of 5. Would equal 2 to the power of 5, which equals 32. Now here, I don't expect you to know powers like this one off the top of your head. So on your calculator, go ahead and plug in 4,861 and raise it to the power of 5 divided by 6. And we should get approximately 7,245.22. Always take it to 2 decimals. All right, for simplifying, for this one right here, we want to take, first let's take the root. If I take the square root of 4, I get 2. And to take the square root of x to the 8, or s to the 8, I'm simply going to divide my power. Would you agree that I'm multiplying here? And so when I divide 8 by 2, I get 4. Now I only took the root, so now I need to raise it to the power of 5. And 2 to the 5th equals, again, 32. And when I multiply these together, I get s to the power of 20. All right, if I'm going to solve the following, hang on. If I want to solve for the ratio of d over d, hopefully you'll agree with me that I have a cube here. I'm going to need to do the opposite and take the cube root, which in a sense is just raising it to the power of 1/3. So I'm going to raise, this right-hand side of the equation to 1/3, so I raise the left-hand side of the equation. Now over here, when I cube root both of these, I'm indeed going to get d over d. And when I cube root both of these, I get the power of 2 and the root of 3 for both. And I'm going to simplify it by raising them both to the same power. If you have questions on that, let's talk about that tomorrow. For tomorrow, I would like you to answer the 2 video questions, and I will see you then.